Okay, hello. Video here on linear equations, bit of intersection, parallel, perpendicular lines. Hope this one helps for you. Most of these concepts are really kind of Year 9 into Year 10 concepts, so hopefully all this is revision for you. Let's start over here with our most common linear equation. So y equals mx plus c is our most common one. We've got to read out what the m and the c actually mean. Obviously x and y are our variables, that's on our axis, x and y, but the m and the c, the m is our gradient. Couple of different ways we can do it here. We can see it as the rise over the run, that is how far do we go up and how far do we go along. We can see it as the difference in the y values divided by the difference in the x values. Now it's important that these little subscripts, they're the ones that tell you which point you're talking about and which part of which coordinate you're talking about. You've got to make sure these are in the right order. Keep the 2's on the left, the 1's on the right. If you flip the whole thing, y1 minus y2 and x1 minus x2, that'll still work out the same number, so that's okay, but you can't flip one of them and not the other. You know, the easier thing, just stick with the way it is, it works every time. This here is another form of notation. This is delta, Greek letter. It just means changing. So the change in the y's divided by the change in the x's, but that's really exactly what this is doing anyway. Any one of these are good. The c value at the end, that's our y-intercept, because when x equals 0, that part, gone, drops out. So y equals c. So that's why that's our y-intercept. You might see this style over here. This style here might come up every now and again. It's not a big style, but let's be aware that we can rearrange that into this format. But we could also see this here. What did I do? I wanted to get that by itself, so I took the ax over to here, became negative ax. Then I divided through by b, that got my gradient. Similar thing with the c here, doesn't really matter about bringing the ax over, I just divided through by b, and I got my y-intercept. So that works just as well if you want to do that. Alrighty, let's talk about intersection. I'm going to assume you're pretty good with graphing them and that sort of thing. If you're not, do a little xy table. You probably remember doing this sort of thing. X here, y here. Plot some x values, maybe 0, 1, 2, 3. Get the y values, plot them, you'll see the line coming up. Let's talk about intersection of line. Let's plot these two actually. 2x plus 2. Y-intercept is at 2. The gradient is also 2. So that's going to give me a line something like that. Because remember, a gradient of 2, that's a 0 gradient. That's going to be a gradient of 1. It's a bit steeper than that. So that's a gradient of 2. So that's that one. Let's call that one y1. So this is y1 there. And then let's do the other one, call it y2. Crosses at 7 with a negative 3 gradient. So from our 0, positive gradients go that way, negative gradients are going down. So that means it's going to come down this way, but steeper than that one. So hopefully I can get this looking fairly good. I'll start here and do this. Hopefully you can see maybe this red one needed to be a little bit steeper, but that's okay. We don't get too worried about it. It's just a sketch to see where we go. If I want to find this intersection point here, then what I'm going to do, because I know y1 equals that and y2 equals that, doesn't that mean that when they cross over, this has to equal that? Because if they're crossing over, their x value and their y value is the same, so whatever this comes out in the y value has to be exactly the same as what this comes out in the y value at that point that they cross over. So this equation here, you can see that 2x plus 2 is that, minus 3x plus 7 is that one. Now I've only got x's. That's nice. Move the 3x over here, I'll get 5x. Move the 2 over there, it becomes negative. I'll get 5. Therefore, x is equal to 1. Kind of marries up pretty neatly with my diagram. That seems like it could be 1. That seems right. So I'm going to then sub in the x equals 1 into either one of these equations. Doesn't matter, we should get the same answer from both. Let's put it into this one. That's going to be 2 lots of 1 plus 2. 2 plus 2, 4. So therefore, x is 1, y is 4. Let's do this one as well. 1 in here, that's minus 3, plus 7, that's also going to get me 4. So I'm pretty happy about that. X of 1, y of 4. Now, oftentimes with these questions, they will ask for the coordinate of the point of intersection. You've got to answer like this, okay? Because this is a coordinate, co meaning 2, the 2 ordinates. Alright? So make sure you finish up your answer like this. If it just asks for the x value or the y value, then clearly you can give one of them. But coordinate, we're here. That's our intersection idea. They should kind of fall out pretty neatly in most cases. You might come through with decimals. If it gets crazy numbers, you've probably done something wrong. Let's talk parallel and perpendicular lines. Parallel lines, well, anything that is parallel is heading in exactly the same direction, never going to cross. So if you do get parallel lines, you should get no answer if you try to do this. Parallel lines will look like this. They could also be going down that way. They both could be horizontal, they both could be vertical, doesn't really matter. The gradient of one of the lines is equal to the gradient of the other. That's how you tell that they're parallel lines. Perpendicular lines, however, cross at 90 degrees. When they cross at 90 degrees, we find if we multiply the two gradients, then they will equal -1. So if you multiply the two gradients and it comes out to -1, then you'll end up with perpendicular lines. A quick rearrangement here, you can see this is also a way to look at it. So one gradient is the inverse of the other, but it's the negative inverse. So that's another way of looking at it as well. Hope this little bit about linear equations helped you. Catch you later.